Lateral flow as a technology is a very straightforward, very effective technology for rapid tests.
So rapid diagnostics are kind of what it sounds like. You're getting your diagnostic answer between 2 to 15 minutes. Unlike the traditional testing methods where there's long incubations, it'll be hours before you get a lab result. Rapid diagnostics means you have your sample and within, waiting at the doctor's office, you have an answer.
So lateral flow is where we take reagents like antibodies or binders that detect certain analytes. We put them onto specific materials like nitrocellulose and different types of pads and wick pads. And then we can encapsulate that into a cassette, a plastic housing, and that holds the device and protects it. Then we combine that with potentially sample handling methods. For instance, taking a finger stick blood, applying that to the test and running the test in very quickly and getting a result on the spot.
So I think the example that comes to mind when you talk about lateral flow is the pregnancy test. That is lateral flow in its most recognizable form. But that same platform where you see 1 or 2 lines to indicate a yes or no can be applied to a lot of different things and not just to tell you whether you're pregnant or not. It could be used to say whether you have an infectious disease like malaria or HIV or COVID-19. So let's get started with making our lateral flow test. So step 1, we want to prepare in solution tubes of our control line antibody and our test line antibody. That's why you see 2 lines. So the test line antibody is the antibody that recognizes the thing you're testing for. So for pregnancy, it's HCG. It can be different for different applications. Once you have them prepared in the solutions, you can then dispense it onto nitrocellulose that we have here. And this is how you get the 2 lines. So I'm going to place my membrane, make sure it's flush to the bottom so that my positioning of the lines is the same from membrane to membrane. And here you can designate the X, the Y, and the Z of these needles right here. First, I want to select the dispense pattern. So I'll select front lines since I'm striping the membrane. And I'm gonna go through each parameter and make adjustments accordingly. And then I hit go. So there's 2 parts of lateral flow. We're dispensing the capture antibody, and then later we will dispense the detector antibody. So I've just finished up marking where the lines were dispensed. I've labeled the control line where we dispensed our control antibody to ensure that the test was run correctly. And then here, our test line, that's kind of the line that we care the most about. That is where our capture antibody is. And then you would let that dry in the oven for 30 minutes. And then the second major aspect of your lateral flow strip is the conjugate. So what is the conjugate? The conjugate is your other antibody that would detect your antigen and form a sandwich. But on that antibody, we'll have a visual particle so that we can see it. When we stripe on the test line, we can't really see the antibody other than, initially when you dispense. So in order to visualize whether 2 antibodies bound to an antigen, we need one of the antibodies to be labeled to a visual particle. And this visual particle will dry down and dispense into what we call a conjugate pad. And then later, we will take all of these and we will put them together to form our lateral flow strip. All right, so now we are going to dispense our detection label. And the detection label, we aren't going to stripe like we did for the capture. We are going to spray it so it's a little bit more spread out. So I'm going to disable our front line since we're no longer dispensing antibody onto a membrane. and I will enable the air jet. And now we are good to go. When we stripe, we're immobilizing it, but here we're only kind of temporarily storing it. This allows us to keep reagent dry down onto a material and allows lateral flow to be run in various different conditions and places. Traditional laboratory tests, you would need to use a pipette in order to use this reagent. But with lateral flow, we can dry it onto this pad, and then now anybody with a plastic transfer pipette or a dropper bottle can run this test. So now that we've dispensed our detector label, we are ready to put this on a screen and dry for 1 hour. And we're now ready to assemble our test. So now it's time to put everything together. We have our dry dispensed reagents. We have our nitrocellulose membrane with our immobilized capture antibody. We have our conjugate pad sprayed with our detector antibody. And one more part of the lateral flow strip is the wick pad or the absorbent pad. This will allow the liquid to flow from the bottom to the top in a continuous fashion. So what I'll need is this backing card. This is what is going to hold all of the different components of my lateral flow strip together. So first I'll take out the adhesive liner, and I will take our membrane where we dispense the capture antibody and line it on the card. And then just to make sure it adheres, very gently press. Then our absorbent pad on top, flush to the top. Though we are still making contact with the membrane, this contact is what allows the liquid to wick through. And in this strip, we are just going to have a conjugate pad. And then just like we did for the wick, we are making sure that there is some contact from the conjugate pad to the membrane. And then press it in place. And then now I have an assembled card ready to cut into strips. Now that we have our assembled strip, now it's time to cut them to our final strip. So we're just gonna load the card here and then adjust our width and how many strips we'll cut at a time. And now we have our final strip ready to put into a cassette. So now that we've cut our card, we have our lateral flow strip, and we are almost done. So at this point, we will place it into the cassette or some sort of device. And at this point is kind of where things start looking like finished products out there. And we'll have a sample port where we'll put our liquid, and then we have a window where we'll see either 1 line or 2 lines. And you can close it either mallet or through this cassette roller. And you have your assembled device ready to run. All right, so now we have our final lateral flow cassette. And I am going to test to see if we get a positive or negative. So I've prepared a positive solution, and we should see 2 lines once it is done developing in 10 minutes. Now at this stage, we are ready to take this test to either other labs for it to be deployed there, or to be deployed out in the field, in your doctor's office, or even at home. That's the beauty of lateral flow.